Hello everyone, my name is Vinod. I study in Vellore Institute of Technology, Chennai, and I am in third year undergrad from Computer Science Engineering Department. And this is my video submission, and my topic is Practical Byzantine Fault Tolerance. What is Byzantine fault tolerance? Byzantine fault tolerance is a property of a system that is able to resist the failure derived from Byzantine general problem. In other words, a Byzantine fault tolerance system is able to continue operation even when some of the nodes fail or act maliciously. What is the sum of the nodes fail and what is this acts maliciously? Things I will explain in the future slides. This is an Byzantine general problem. Here we see there are this four kings or generals who are gonna attack, and this is the castle which are gonna be attacked. This is a general problem, and from this problem we're gonna connect it to the blockchain topic. How this problem is used in blockchain as well, we're gonna learn it from this real life application. So this is an general, this is an general, this is an there are four general, and there will be a lead general who gives command to the four general, and this is the castle which is gonna be attacked by this general, and how the things are work will be explained in the future slides. What is Byzantine general problem? First, imagine there are four divisions of Byzantine army camped outside the enemy cell, like I showed in the previous slide. The general can communicate with one another only by messenger. After observing the enemy, they must decide upon a common plan of action whether to attack the city or retreat from attacking. There are only two things possible. Either they go attack the castle or they go retreat from attacking. And there might be a traitor general among the general. Traitor usually in any group there will be a traitor. So similarly, even from within the generals, there might be a traitor as well. Even if there can also be a possible of there is no traitor as well, and this traitor creates an important problem between the generals, which we will see in the next slide. The main problem is that majority of the generals should either attack or retreat to win. So this Byzantine general problem mainly works on the majority concept. Either if majority of them supports either attacking or retreating, they just follow that. The problem is how will the general come up to a concise on action that they are gonna take in order to win. Now let's see an example of how things works. Here you see there is a general 1, general 2, general 3 and general 4, and they're gonna attack this castle. There are multiple cases possible, and let's go through each and every cases and what things can be done. First, let's take the general case. There is no traitor at all. So this general all has the same intention. Suppose let's say he is the chief general. Let's say he gives the command to everyone. For what he says is, let's go attack the castle. To the second, let's take them as R1, R2, R3 and R4. So what he does is, he says let's go attack the castle to R2, and same thing to R3 and R4 as well. Now what happens is, the R4 listens the command which he receives from R1, and he says okay fine, this is the command I received. Just accepts the command from the general and he says this is what I'm gonna do. So he's gonna say I'm also gonna attack to R2, R3 as well as R1, which is not necessary as well, but okay. Then similarly, R2 receives a command of attacking the castle from R1, and he does the same. of telling other general that he's gonna attack. So he's gonna say he's gonna attack to R4 as well as R3. The same with R3 as well. He's gonna say he's gonna attack and to R3 and R4. You can see here he receives three commands, that is from R1, R2 and R3, and all three of them stating to attack. So what does it mean? That he is having the majority of them, and here everybody is telling him to attack, so he goes and attacks them. Now similarly R1 is the general and he is not a traitor, so he will go and attack as well. Now R2 also receives three commands, that is this one, and this one, stating R2 should go and attack. So he will also go and attack the castle. Similarly R3 also will go and attack castle. In this case everybody will go attack the castle and the castle gets destroyed. Now let's take the next case. Suppose there is a traitor. Suppose let this be a traitor. R1, R2, R3, R4. Let us assume R2 as a traitor. What does traitor do? Now the general says he should go. Everybody says to everyone that they should go and attack the castle. One, he's saying to R2 he should go and attack. He's saying R3 to go and attack. He's saying R1 to go and attack. So first let's see the R3 and R4. What this R4 does? He receives the signal from R1 and tells R3 and R2 that he is gonna go and attack because he is not a traitor. He receives the signal from R1 stating he needs to go and attack. So he tells R1, R3 and R2 that he is gonna attack. Now similarly R1 receives signal from R3 receives signal from R1. Now he just goes and tells other that he is gonna attack them. So he tells R4 that R3 is gonna tell R4 he is gonna attack. Similarly he is gonna tell R2 that he is gonna attack. Now since R2 is a traitor, what he can do is he can say is he is not gonna attack. So what R2 is gonna say, he is not gonna attack to R4. Similarly he is not gonna attack to R3. You can say whatever he wants. Let's assume that the traitor is gonna tell them to retreat from the castle. So he is saying R4 that is not gonna attack, R3 not gonna attack, and R1 not gonna attack. Now what happens? Now this is the very important concept we should know. Now we can see number of incoming calls is 1, 2 and 3, in which the majority of calls are saying to go and attack. That is, two calls are saying it's gonna go and attack, and one call is saying to retreat. So this general will follow the majority call and he will go and attack the castle. Similarly with R3, there are two incoming calls saying to go and attack the castle and one incoming call saying to retreat. He follows the majority and goes and attack the castle. Then R1 being the general, he obviously will go and attack the castle. So in this way the castle gets destroyed in this case. Now let's take another example. R1, R2, R3, R4. Now let's take this example of mixed signals. R1 tells R2 to go and attack, R4 to go and attack, R4 to go and attack, and R3 to go and attack. So let's assume R2 as traitors. R2 is our traitor. Now since R3 and R4 are in traitors, what R4 does is it tells R3 that he is going to attack. He is going to tell R2 he isn't going to attack. He is going to attack. He is going to tell R1 he is going to attack. Similarly, R3 is going to tell R1 he is going to attack. He is going to tell R4 he is going to attack. He is going to tell R2 he is going to attack. Now, what does this traitor does? We can't say that every time he just the traitor will give single signal of either go on attack or not attack. This time he gives mixed signal, that is, to r1 he says he's gonna go on attack, and to r2 r4 he says he's gonna retreat, and to r3 he says he's gonna attack. He can give mixed signals as well. So now there are mixed signals between r1 r4 and r3. He tells to this r2 tells to r1 and r3 that he is going to attack the castle, and he tells to r4 to retreat. Now what happens? r1 has every signals pointing to attack, and everyone telling him to attack, and he is a general, he is going to attack the castle. r3, what he does is, every signal he receives says that he should attack the castle, thus he will go and attack the castle. Now what r4 does is, he just checks the majority of the condition, that is here two condition says to attack the castle and one condition to retreat. It follows the majority and attacks. This traitor can do whatever he wants. He can either attack or retreat, that is because he is a traitor, he can do whatever he wants. Now the majority of people attacks the castle, thus the castle is destroyed. That is the reason why I am going so deep depth in this concept, because after learning this concept very well, we're going to link it with the blockchain concept. Now let's assume this time there are multiple traitors. Now the traitor 1, traitor 2, r1 r2 r3 r4. Let's assume there are multiple traitors, and we can assume anything as mixed signals or whatever we want. Now what does traitor 1 says? He is saying to saying everyone to attack. He is saying r2 to attack, he is saying r3 to attack, he is telling r4 to attack. What this traitor 2 does is, he just gives mixed signals. That is, he tells r1 not to attack, he tells r2 not to attack, he tells r4 to attack. Now what r4 does is, he takes the signals and he says signal from the r1, because he is the general, and he tells everybody he is going to attack. Similarly with r3, the signal he received from the general is to attack, so he goes and tells everybody that he is going to attack as well. He is going to tell everyone he is going to attack. Now let's see what happens. Now r1 and r2 are traitor, and we know that. Now r4 and r3. Now r4 receives all the signals asking him to attack, so he goes and attacks. Now r3 has majority signals being asking him to attack, and the minority signal asking him not to attack, thus he goes and attacks. Now r1 and r2 being the traitors, they either attack or wouldn't attack. Let's assume they don't attack, so they retreat back. What happens here is, since the castle isn't attacked by the majority, more than the 50% is, we can't say it is majority or minority, since it is not more than the mean, that is more than 50% of them aren't going and attacking, thus we can't say that the castle is being 100% captured. This is a very, very important point to note, because this plays a very, very important role in the future slides which you're going to see. Now I think you understood the basics of how this works, and let's now go and link it with the blockchain and read. Now this is the I explained the algorithm orally. Now let's see what the algorithm is. We can observe that consequence algorithm followed by the general as we perform the action that is communicating by the majority of the general. If it does maximum people ask them to retreat, it will retreat, else it will go and attack. So that's what it says. And we also observe that the consequence algorithm works only when there are at most n traitors among 3n plus 1 general. That is, at least maximum number of malicious general must not be greater than one third of the general in the scenario. What is this one third? The last case which we saw here, there were two traitors, which is there are two traitors. That is, the number of total number of general is 4, and there are two traitors. That is equal to 1 by 2. 1 by 2. It is more than one third. One third. Thus, we can't say that the cache list being fully captured. That's what suppose if there is only one traitor, or the number of general is more than 4. Suppose we add two more general and we choose two traitor. This would work because it is 2 by 6, which is 1 by 3. 2 by 6, which is 1 by 3. This ratio shouldn't be greater than 1 by 3. If it is greater than 1 by 3, this won't work. The maximum number of malicious general must not be greater than or equal to one third of the generals in the scenario. If it is more than one third, then mostly they will retreat and the castle won't be captured. So, how is this problem related to blockchain? We can relate this dilemma to blockchain, where each general represents a network node in which to reach consensus on the current state of the system. This means that majority of the node in the distributed network must agree and execute the action in order to avoid failures. This is a very important point, because suppose let's keep 4 nodes, and majority of the nodes should accept either to accept a transaction or cancel the transaction. Only then the transaction will happen. Either majority accepts, the transaction might happen, else the transaction won't happen. Now, to make it more clear, let's see what is this practical Byzantine fault tolerance. Practical Byzantine fault tolerance is a consensus algorithm. The goal is that all honest nodes help in reaching a consensus regarding the state of the system using the majority rule. The PBFT algorithm is as follows. There is one primary node, which is here we related with the general there. The general is considered as the primary node. Now we read by linking both the general castle capturing as well as the blockchain. So we call that one node as primary node, which is the general, and the other nodes are secondary nodes. The nodes here are the generals. Any eligible node in the system can become primary by transacting from secondary to primary. And it consists of three phases: prepare, and commit. First, the client sends the request to the ledger, which is the primary node. Then the primary node broadcasts the request to the secondary nodes. The nodes primary and secondary perform service request and then sends back the reply to the client. The request is served successfully when the client receives n plus 1 replies from different nodes in the network with the same result, where n is the maximum faulty nodes allowed. That is, if there are 5 faulty nodes allowed, then there should be at least 6 reply. That is more than half to accept it or to allow the transaction. If there are 2 faulty, there should be at least 3 nodes which says the capture. We'll take the example of the castle itself. Suppose if there are 2 nodes to be as traitor, 2 general to be traitor, there should be at least 3 generals, true generals, so that the castle needs to be captured. That only then it will come more than the ratio of 1/3. Here it will be 2/5, which is greater than 1/3. Now, see this example. Here first this 0 is the primary node or the main general. First there is a request being passed on, and from the main general it just goes to everyone. Similarly from this node he prepares to Rusty, Gloria and Nader. Let's assume that the Nader is a faulty node. Then what happens is each of them does the preparation phase. Each of them does the preparation phase. After that it commits the changes across all of them. Since neither node is a faulty node, there won't be a reply from this from Nader, and other three will reply. Now what we can assume is we get a maximum of 3 replies out of 4, which is more than 1/3. That is one faulty, 3 replies, which majority of things which we things is majority we get a reply. Thus this node is accepted, this transaction is accepted. What is an advantage of BFT, PBFT? Energy efficiency. PBFT can achieve distributed constraints without carrying out complex mathematical computation like proof of work. There is another method called proof of work, which also does the same same thing of verification. But what we do in a proof of work is we take a function and we do a hefty calculation to prove that this transaction is valid or not. Whereas here we just do a maximum checking, maxima checking, which is max O of 1 time complexity. Thus the energy is more conserved here. Transaction finality. The transaction do not require multiple confirmations like in the case of POW mechanism in Bitcoin, where every node individually verifies all transactions before adding a new block to the blockchain. Confirmations can be between 10 to 60 minutes depending upon how many entities confirm the new block after they had been finally and approved. Low reward variance. Because every node in the network participates in responding to the client's network request, each node can be motivated, resulting in a low variation in paying the nodes that assist the decision making. I think this concept is clear to you. And I hope this concept is clear to you. If you like the if you understand well, do like the video. Thank you so much. See you in another video.